In today's video, we are going to be talking about complex numbers, and it is right here on the board. Okay, now complex number is quite an important topic. Okay, for those persons that you probably just got into the university or in your SS3, as most schools tend to go advanced. Okay, but still, it is a very important topic, and that is why we're going to talk about it. First of all, you need to know what a complex number is. How do you identify a complex number and every other thing that comes with it? We might not be able to cover the whole thing in this video, but then in subsequent videos, trust me, we are going to deal with a whole lot, okay? As it is quite a broad topic, okay? Now, first things first, you should know that complex numbers are numbers that will always contain two things. First things first, we'll have a real number, and then we'll have what we call an imaginary number. Okay, so we have a real and an imaginary number. So complex numbers are numbers that contain both a real and then an imaginary number. Now let's take our mind back to what we call the number line. Okay, now for a number line, it contains real numbers. Okay, I guess the number line that everyone or probably everyone watching this video is acquainted with is the one that contains real numbers only, in the sense that we have a 0 here, we have a 1, a 2, a 3, and so on and so forth. And to the left hand side of the 0, we have negative numbers. Okay, we have negative numbers in decreasing orders to the left and in an increasing order to the right. And then on the center part, which is the vertical, there comes what we call the imaginary number. Okay, the imaginary numbers are found on this part of a number line. Okay, so we have -1 j attached to it. I've not explained what j means yet, but we're still going to talk about it. Okay, and we have -2 with a j, -3 with a j. Okay, and upward we have +1 with a j, +2 with a j, +3 with a j. Okay, now imaginary numbers are represented using the symbol or the alphabet I or J, depending on which book you're trying to cover it on. But most textbooks you find I, okay, of which J can also be found in some of the textbooks. So I'm going to write in bracket imaginary numbers are represented using an I, okay, or a J. Now, how do you know if you're having an imaginary number rather? Imagine we're having -4j. You could see it as just a normal number, okay? Because of course in algebra we make use of alphabet in solving questions, so you might see it as a normal number, okay? For that reason, most times or usually we write the alphabets before the number to show that it is actually an imaginary number. So instead of writing a -1j, we might want to write it as -j1. Okay, might want to write it as -j1, or rather -i1. You might not find -i1, you might find -1i, because I is the most common. Most persons don't bother writing it in front. Okay, I've seen the question will definitely tell you if it is a question under imaginary or complex numbers. First things first, to understand complex number, we need to first dive into the world of imaginary numbers. Now, what are imaginary numbers? I just gave you on the number line, that is for mathematics, okay? But in a normal sense, first of all, you need to find out the meaning of the word imaginary. First of all, what does the word imaginary mean? Okay, when we say something is imaginary, it simply means it is not real. Okay, so you see these two guys are opposites of each other. Okay, so we have imaginary and real. Okay, imaginary, it does not exist. Okay, but in maths we are still going to talk about it. And then for real numbers, it means it's actually what now exists. Now for imaginary numbers, I just said they're represented using I or J. Okay, now let's dive into the world of imaginary numbers. So I'll start here. We have what we call the imaginary numbers. Okay, I just explained what it is. Okay, imaginary numbers, they are not real. Okay, but we'll assume they exist just so we can work with them. Now, when dealing with imaginary numbers, The first thing that should come to your mind as a student or someone that wants to understand what it is the square root of negative numbers. Okay, but first of all, if I should write out the square root of some following numbers, you can pause this video and tell me what they are. Okay, and then you place it to check if it's correct. So I write out the square root of some numbers, of which these are the numbers. We have a 4. Square root of 4 is simply plus or minus 2, of which most times we use the positive one depending on the situation. Okay, because both are actually correct. And then we have the square root of 16. It is going to give us plus or minus 4. And the square root of 8 can only be broken down. Okay, so let's say a plus or minus 2 root 2. Okay, or you can put this one in decimal form, it doesn't matter. Okay, most numbers do not have they are not perfect squares, so their square root tend to end up in decimal form, which you can write this one, which will be 1 times 1.42 or 1.41 rather, which should be 2.82 if I'm not mistaken. That should be the square root of 2.82. Okay, now that is by the way. We just found the square root of 3 different numbers, of which you notice that the square roots of the numbers we're looking for are actually positive. That is, we are taking the square roots of positive numbers only. Does that mean that negative numbers do not have square roots? Of course they have. Okay, now the square root of negative numbers gives us what we call the imaginary set of numbers. Okay, that is, we do not know what they are actually. Okay, but we can use certain symbols or notations to identify these numbers. I'm going to start from a very easy value, a common one, okay, which is the square root of minus 4. So if you're asked what is the square root of minus 4, what you might want to say is there is no way I'm going to obtain the square root of minus 4 because this is a negative number. What numbers do I multiply to get negative? Of course, there is none. For that reason, there is something we do. Now, what is that thing we do? We assume that the square root of minus 1 at any point in time is equal to j. That is what we do. We assume that the square root of minus 1 at any point in time is equal to what? J. Okay, so it means when we're given the square root of negative numbers, we can as well bring in what now? J. We can incorporate it. Okay, that is what we're going to do. So we can then find the square root of minus 4. Okay, in the sense that the square root of minus 4 then becomes square root of minus 1 times 4. Okay, using the laws of surd. We're having square root of minus 1 times 4. Okay, now we can use the laws of surd to break this down. And the law of surd is saying if you have the square root of a times b, it is equal to the square root of a, okay, the square root of a times the square root of b. Now please take note that if you study the laws of surd and you've forgotten, you might want to also work out the same thing for a plus here or a minus here. No, it doesn't work. Okay, it only works when having a plus and a times and a division sign. Okay, it doesn't work for plus and minus. Okay, there are laws to use and you should watch videos on that or study books on that. Okay, since we've not done that yet. Now we're having square root of a times b, which equals square root of a times square root of b. Okay, that is one thing. Now if we apply the same law to this, we are going to have the square root of minus 1 times the square root of 4. Now the square root of 4 is 2. Okay, so I'm going to have the square root of minus 1 times 2. Right? Now the square root of minus 1, we said anytime we have the square root of minus 1, it should be equal to j. So when I place in j there, I'm going to have j times 2, which gives us what now? J2. So we can now say that the square root of what? Minus 4 is j2. Where the value of j is what now? The square root of minus 1. So whenever you see j, it simply means we're having what? The square root of what? Of minus 1. Okay, now let's try other numbers and see. When we try to find the square root of minus 16, what you should be getting should be the square root of minus 1 times 16, which equals the square root of minus 1 times the square root of 16. Okay, and that equals square root of minus 1 is j. So we're going to have j times square root of 16 is 4. So that gives us j4. Now you notice the square root of minus 16 to be j4. Why? Square root of 16 is 4. Square root of minus 1 is what now? J. So instead of going through this whole step while solving, you can as well skip from here to here. That is, when you are told to find the square root of a negative number, what you should simply write is J in front of the square root of that number without the minus. What am I trying to say? The square root of minus 4 is J2. Okay? Throw out this minus, find the square root of 4 to get 2 and put J in front. Square root of minus 16 is J4. Throw out this minus, square root of 16 is 4 and put J in front. So we can as well write the square root of the following numbers to be square root of minus 25 will equal J5. Okay? The square root of minus 49 to equal J7 and so on and so forth. Okay, now these numbers that have J or an I attached to them, of course you should take note in the context of the question given to you that J or I do not represent alphabets, but rather they tell you that they are representing imaginary numbers. So whenever you have them attached to numbers or standing alone, most times, okay, they could as well stand alone with powers or with no powers. Okay, now whenever you're having these two guys attached to numbers, what do we call those numbers? We call those numbers imaginary numbers. Okay? We call those numbers what now? Imaginary numbers. Now, how about the other aspects of the complex number we just did? We're having what now? Real number on that side. Okay? How are real numbers work with? Okay? What do we see real numbers are? They are simply the opposite of imaginary numbers. Imaginary numbers, we know they do not actually exist, but we try to bring in notations to work with them. Okay, now for real numbers, they are the opposite. Like I said, real numbers, they exist. They are your numbers we have positive and negative numbers, natural numbers, whole numbers, fractions, and the likes. They all fall under real numbers. But immediately this J or I comes in contact with these real numbers, okay, we call them what now? Imaginary numbers. That's the only difference. But do take note that if I have, for example, J5, this is an imaginary number. But when we have J plus 5, there is a J here and there is a 5 here. This is not an imaginary number. Take note of that. This is an imaginary number. This is not an imaginary number. Now, why is the first one an imaginary number and why is the second one not an imaginary number? It is simply because when we are having two numbers adding each other, it does not tell us that it is what now? Imaginary. In the sense that, in this case, J can be written as J1. So over here, we have an imaginary number. Okay? J1 can be represented, J can be represented as J1, which means it is an imaginary number itself. And then 5 on the other hand is a real number, right? And then we're having a combination, imaginary and real number. A real number and imaginary number is what forms what now? A complex number. So what we are trying to say is that whenever we're having a combination of a real and an imaginary number, it is what forms out what we call the complex set of numbers. Okay? That is simply the definition. A complex number includes a real number and an imaginary number. So I'm going to note something on the board on this side, which will say that, okay, it is going to say that complex numbers are composed of a real and an imaginary number. Okay, that is the definition of a complex number. A complex number is simply a number that has what now? An imaginary and a real part. Okay, that is what it's simply telling us. So I can write different examples of complex number based on the fact that I've explained imaginary and real numbers. Okay, so I could say that J plus 5. So is it a complex or a real number or an imaginary number? It is simply what now? A complex number. If I have J5, is it a complex or a real number or an imaginary number? It's simply what now? An imaginary number because there is no real part. Okay, if I have, for example, J minus 6, is this a complex or a real number or an imaginary number? It is a complex. There is an imaginary part and there is a real part. So if, for example, I have 2 plus 3J, is it a complex, a real, or an imaginary number? It is a complex number because we are having an imaginary part and then a real part. So this one is as well what now? Complex. Then what are real numbers? You don't have to find this J attached to them. Once you just see a number and there is no j or an I attached to them, it means what now? They are real numbers. That is what it simply means. Okay, so I believe that is very, very clear. Now there are other aspects that we're going to talk about for complex number, which include addition of complex numbers, multiplication of complex numbers, division of complex numbers, subtraction of complex numbers, and then there are other aspects we also want to talk about. Okay, those aspects include the various ways that represent a complex number. We have what we call representation of a complex number. Okay, we could use what we call an Argand diagram. Okay, we could represent them in exponential form, and we could represent a complex number in polar form. Okay, but before we get into that, let's talk about the addition, subtraction, division, and multiplication of complex numbers. Okay, now first things first, I'm going to talk about the addition of complex numbers. Okay, let's talk about the addition of a complex number. Now, to add a complex number, okay, to add a complex number, the real and imaginary parts, to add a complex number, the real and imaginary parts are added separately. Okay, now what do I mean by this? That the real and imaginary parts are added separately. Let's say we are having a question, okay, giving us 2j or 2 plus 3j, okay, this is one complex number and it is being added to another complex number which is 1 minus j, for example. This is a complex number, this is another complex number, and we're summing both of them up, which is addition of complex numbers. Okay, now to do that, what we are going to do, we are going to add the real part. This is the real part. For this complex number, this is the real part, this is the imaginary part. This is the real part, this is the imaginary part. So we are going to add the real part separately and add the imaginary part separately. It's as easy as that. So I can as well write two of them first. That will become 2 plus 1 as the real part, plus the imaginary part we have 3j plus we have minus j. Okay, so for me we can go ahead and add 2 plus 1, that gives us 3, plus 3j minus j, that gives us what now? 2j. Very, very easy. Okay, so for the addition of complex numbers, what we are simply going to do, we are going to add the real part separately and then we'll add the what now? Imaginary part separately. There are different examples you can practice with. I'm going to drop one here. Okay, so here is an example which is 3 minus j4 plus 6 plus j5. So if you are asked to solve this, add these complex numbers together, what are you going to do? We are going to add the real parts and add the imaginary parts. So we're going to have 3 plus 6, which gives us 9. Okay, j5 minus j4, that gives us what now? Plus j or j1. Okay, you should know that j is same as j1. Okay, so it's as easy as that. We're having 9 plus what now? J as our answer. Very, very easy. Now, how about subtraction of complex numbers? Let's take a look at subtraction of complex numbers. Same procedures and methods apply. So I'm not going to write this again. Okay, I'm just going to write subtraction of complex numbers. Subtraction of complex numbers. Okay, now how do we work with subtraction of complex numbers? It is quite easy. We are applying the same method. So I'm going to take every of these examples and put a negative at the center. Okay, I think that will make it easier for us. So for this question, we're having 2 plus 3j, okay, minus 1 minus j. Okay, that is the question. Now to work this out, we are going to add the real, we are going to subtract the real parts rather, and then we are going to do what now? We are going to subtract the imaginary part as well. Okay, so 2 minus 1 is what now? 1. 3j minus j. Okay, notice that there are two minus here. So you have 3j minus 1, minus j rather. That will be 3j plus j. That gives us what now? Plus 4j or plus j4. Okay, I told you it's better to write it in form so you don't mistake j for just any random alphabet. Okay, and then for the next question, we are going to have 3 minus j4 minus 6 plus j5. Okay, that is what we are going to do. Now to subtract this, 3 minus 6 is minus 6, right? And minus 3 rather. Okay, minus j4 minus j5. What are you going to get? So I'm going to get minus j9. So is that easy? So for addition and subtraction of complex numbers, all you have to do is add up the real parts and then add up the imaginary parts. That's for addition. And then for subtraction, we are going to subtract the real parts and then subtract the imaginary parts. So is that easy? Now next thing, what's left is to talk about the multiplication and division of complex numbers. Okay, now for you to divide complex numbers, you have to have a knowledge of multiplication of complex numbers first. Okay, that's one thing. For you to divide complex numbers, you need to have a knowledge of the multiplication aspect of what now? Complex numbers. And then for multiplications of complex numbers, we need to have an idea on the powers of complex numbers. Okay, now this is something we are going to talk about in the next video, of which the link to the next video will still be in this description. Okay, it's going to be titled powers of complex numbers, multiplication as well as division of complex numbers. So do well to like and subscribe to our YouTube channel. Okay, and now like this video if it did help you, if it did give you an intro and insights of what complex number is about. Okay, and you can also learn more by clicking on your notification bell, so that when a new video comes out, you will be one of the first persons that gets to be notified about it, and then you can learn more, just like I said. And also invite your friends to subscribe to the YouTube channel, as we provide not just classes on maths but other science courses as well. Okay, now like I said, I'm going to put the link to the next video that continues these aspects of complex number, which is the power, the division and multiplication. Okay, in the description. And if you can't find it in the description, or you don't know how to do that, all you have to do is search for the next video. Okay, complex number Dr. Flash. It will give you all the videos that I have done on complex number. It's going to come out on YouTube. Okay, so see you in the next time. Have a good day.